Okay, so hi everyone. My name is Clinton Knight. I'm a software engineer on our team in North Carolina, where we focus on our integrations with Docker and Kubernetes. So we've heard about containers today. So let me show you what we're doing with that. So over the last 20 years, we've seen a migration from installing applications on bare metal to installing applications in virtual machines for better utilization of hardware and efficiencies of space and power and cooling. Well, now we're witnessing another shift to deploying applications in containers. Again, it's a quantum leap forward in all of those efficiency metrics. We can run a lot more applications on a given hardware base, and that's really what we need to do, especially in shared environments like clouds. So containers can run pretty much anywhere. They bring all of their needs, all their libraries, all of their binaries and everything with the pre-built images that you run containers out of. So they're super fast to deploy. All right, we heard earlier that starting the DevOps journey is about optimizing for speed. The containers fit really well with that, okay, because you can start a container application with a single invocation to Docker or to Kubernetes. You can scale it up or down equally trivially with a single command to Kubernetes. So containers are a very, very good fit for Agile or DevOps environments. So at scale, you need to be able to run Kubernetes across a cluster of compute hosts. The last few years have seen the emergence of a number of container orchestrators. For a while, it wasn't clear if one of those would achieve a dominant position in the industry. But as 5 years of Google search history shows us, Kubernetes has, in fact, won that war, achieved that position of dominance as the container orchestrator of choice. So it's not hard to understand why Kubernetes is deployed at massive scale. It's got the most open source, or most active open source community on GitHub and the like. You don't have to run Kubernetes yourself. If you're just getting started, I would suggest that you take advantage of one of the managed Kubernetes services that are available in virtually all the public clouds. Some of these services have just been made available earlier this year, such as in AWS and Azure. So I've played with a number of these in my day-to-day work, and I'm actually happy to report that the NetApp Kubernetes Service that we announced a couple of months ago is easily as good at and in many cases better than any of the others. The difference with NKS is that NetApp is not going to be hosting the compute resources for the Kubernetes clusters that NKS is deploying. Instead, NKS is a sophisticated yet very user-friendly automation layer on top of the public cloud of your choice. So it doesn't matter if you prefer Google or Amazon or Azure, NKS will happily provision and manage and upgrade Kubernetes for you. Okay? So I just want to show you a demo with a couple of parts. The first, I'm going to use the NetApp Kubernetes Service to deploy a Kubernetes instance. Okay, and then I'm going to skip the part where I install and configure our storage orchestrator, Trident, because my colleague Ardalan is going to follow me and show you more about Trident. But then once Trident is deployed in the cluster that we're about to deploy, I'm going to set up a multi-replica web server and show you just how simple that is and how fast that is when we're doing it with containers. All right, so this is the NetApp Kubernetes Service UI. I don't have a cluster here yet. So this is the control plane view of my clusters. If I click Add a Cluster, here's my choice. I can pick my cloud, Amazon, Google, or Azure. So I'll start with Amazon. Just a few choices here. I can say, use my AWS credentials, because I've already entered those. And then I can change some of the defaults. By default, I get one master and 2 workers. I can change that. I can say, I want some bigger machines or some smaller machines. Choose what region I want to work in. Because I've already given it my AWS credentials, all of my network identities are here. I can take the defaults or tweak them, whatever I want. So now I'm done on this screen. If I hit submit, I'll go to the second of 2 screens. And here I can choose to change my cluster name, pick what version of Kubernetes I'd like for them to start with. tweak the network settings if I want, change the Linux distribution. I'm just going to take those defaults and click Submit. So at this point, NKS is now spinning up virtual machines and installing Kubernetes within AWS. The process takes 10 to 12 minutes or so, at which time Kubernetes is running in my cloud account. So if I drill into it, we can see some of the details of what it did. We've got one master, 2 workers. We can just add additional nodes trivially by clicking these buttons here. We can see some of the other deployments that NKS deployed by default in the Kubernetes cluster. So they actually proxy the API servers and then provide a link directly to the Kubernetes UI. So that's really handy. So again, from a Kubernetes perspective, we can see what it's deployed already out of the box. So NKS is not only about deploying Kubernetes, but they can also deploy a number of utilities and applications using Helm charts that are available out of the box. Quite a number of very common, popular applications that people run in Kubernetes. Or if you have your own custom Helm charts, you can import them here, and NKS will manage those for you as well. Okay. If you're running multiple Kubernetes clusters, NKS can set up what's called an Istio service mesh across your clusters so that the clusters can communicate. So now let's go deploy a web server. So at this point, like I said, Trident has already been installed, so we can, and it's been installed on our Cloud Volume service. So what I'm going to do is I've got a YAML file where I've defined 3 objects: a persistent volume claim to request storage for my web server application, a deployment where I ask for 2 replicas of Nginx, the web server I'm using, and finally a service object which Kubernetes uses to communicate with the underlying cloud provider and set up a load balancer across those replicas such that it looks like one coherent application to the outside world. So at this point, Trident is active. It's noticed the PVC that I've entered asking for storage on NetApp Cloud Volume Service. It takes a few seconds for the service to provision the volume. But in less than 30 seconds, we have a bound volume. As the administrator, I can look and see the persistent volume that goes with that PVC that it's bound to. Since the storage is there, now the 2 pods that I asked for should be running, and they are on different nodes. So now I've got a 2 replica web server running. The service takes a little bit longer because it's got to coordinate with the underlying cloud provider, set up the Elastic Load Balancer in AWS, and it takes a little bit of time for the DNS propagation to happen. So while I was waiting here, I copied some static data into the storage that I just provisioned. And I came back a few minutes later. I think it was about 9 minutes. And then when I click on the service link here, I can see that now we have an external endpoint that's been provisioned and set up in DNS. So when I click it, I can hit this web server across the public internet. And so remember, starting the DevOps journey is about optimizing for speed. And so if I were to have to do this again, starting with an empty cloud account, I can use NKS to stand up Kubernetes, deploy Trident, and then deploy a multi-replica, HA, high throughput web server accessible across the public internet in less than half an hour, including all of the waiting time. And so DevOps is really about going fast, and containers, NKS, cloud volumes are tools to help you get there. Thank you.